Hi, Lindsay. So today we're going to look at our final section of Chapter 7, which is Geometric Series. So again, Geometric Series is still adding the terms together of a sequence, but this time the only difference is that the sequence of numbers have a common ratio. So these next I guess a couple paragraphs here sort of shows how we get these equations. If you are curious, I'd definitely recommend looking up a YouTube video on how this equation came to be. But for our sake, we're going to focus on how we're going to use it. So to find the sum in a series, in a geometric series, we use this. And this t to the n gives us, again, any term that we plug in. So once again, the key things to remember here is that a, as we looked at before, is the first term, r is the common ratio, n is the term number, and again this a to the r to the exponent n minus 1 represents this last term here. Okay, so what we're going to do is calculate the sum of this following geometric series. How do we know, again, that it is a geometric series? That's the first thing we always have to find. Is it arithmetic or is it geometric? So in this case, we have 2 to minus 10. So what we're doing in this case is multiplying by negative 5, minus 10 to positive 50. We're also multiplying by minus 5. And positive 50 minus 250, we're also multiplying by minus 5, and so forth. So we can see in this example here that the first term is positive 2. This common ratio is negative 5. And what we want to find is this SB. This should be SN. That's my apologies. Okay, what is this sum? So because we know this is geometric, SN is going to be A. We use our general equation, which is just right here, to the R to the exponent N minus 1 all over R minus 1. So we have the first term, we have the common ratio. The only thing that we're missing though is this n value. How many terms are in this sequence here? Okay, what is this n for this 156, 250? What is that n value? So what we can do is use that last term and solve for this missing n value. Okay, so in this case, we have t to the n, so that's what we're not sure of, but that is our last term. So we're going to replace that with minus 156, 250, and that's equal to 2, which is our a. The common ratio is minus 5, and then we have n minus 1. So again, this is the n that we want to try to find. First thing we can do, divide both sides by 2 to get rid of this. And we're going to be left with minus 78,125. And it's going to be equal to minus 5 and minus 1. So the easiest thing that you can do here, I mean, you can take the log of both sides and move forward from there. But one thing we can also try to do is, can we put this to the base of minus 5? So through a little bit of trial and error, take a couple seconds for that, you'll find that we can put this to the base of minus 5, and that's going to be the exponent 7. So what we can simply do is just have this exponent 7 equal to this exponent here, n minus 1. So we add 1 to both sides, and this is simply n is equal to that 8. Proper form, we put our variable first, and we can now use that to find the sum in this series. So we know that this right here is the 8th term. Okay, so to find the sum of this, we can do S of 8 is equal to A, which is 2, the first term. R is minus 5. Subtract 1. and this is all over -5 minus 1. And we're just going to take this one step at a time using BEDMAS. So now we can do 2 inside this set of brackets here. If you calculate that, it's going to be 390,624. And on the denominator here is going to be -6. And when we calculate this fully, this is going to be -130,208. So that gives us our sum of this particular example here. So let's take a look at our last example. So binary numbers are combinations of base 2 values. So all of these can have a base of 2. So for example, this is 2 to the exponent 0, this is 2 to the exponent 1, 2 to the 2, 2 to the 3, and 2 to the 4. So we want to calculate the sum of the first 12 binary numbers. Okay, so once again, the sum is equal to A, again, geometric, because to get to 1 to the 2, we multiply by 2. 2 to 4, we also multiply by 2. Multiply by 2, multiply by 2. Because we know that, it's going to be geometric. So we can look at this equation, r to the n minus 1, r to the n minus 1, sorry, over r minus 1. A in this case is the first term, which is 1. The common ratio is +2. That's what we're multiplying by. And n here tells us here the first 12 binary terms. So, we're going to take this and we're going to substitute the numbers accordingly. So 1, common ratio is 2 to the 12 minus 1. And this is our ratio of +2. Subtract 1. And when we get this, you are going to get a final value. Again, what I'd suggest is simplify the numerator, simplify the denominator, which in this case we're lucky is equal to 1. And you get the value of 4,095. So once again, when you're doing these questions, especially for the review, the first thing you need to determine, is it arithmetic or is it geometric? Knowing this determines which equation that you can move forward with for the rest of your question. And that concludes our lesson for today. Thank you for listening.